look at, okay, we'll do a live demo, just to lay foundation on where we are going to, right? So what at the end of this program, you should be able to what to boldly describe, okay, how you implement CI/CD, continuous integration and continuous delivery plus or continuous deployment. Now, what is the difference between these two? First of all, what is continuous integration? Let's look at that. I think I have a, okay, see that? So what, we have a diagram like this. Again, do you see how we have a source code here? Okay, so what, this is where we are at the moment. So what, we are here to get to our build server. That's going to enable us to set up what, build automation. Because again, the goal is not for developers to manually build a code. That was years and years and years and years ago. So in every modern software development team, as we speak, there is a concept of what, of build automation. How can we automate this entire life cycle, right? So now what? So if we have these developers, just like what we did yesterday, right? You could see, Joe, right, pushing to the source code, and of course, what Marble again, what pushing, but what something very unique there. They were pushing pushing on their branches. Can we then what, like, can we now, enable them to push, okay, on their branches? Then what that commit on their branch is able to then trigger a build in the back end. Is that possible? The answer is yes. So now what, in this demo, let's explore the technologies that we are going to be looking at and what they stand for. First, what we know our source code. This is where we are as at date. Okay, I have this. So this is where the source code of the application of the software is going to be hosted, and in most cases, private repositories. Today, we are going to look at how to work with private repos, because that is what you're going to do at work. No company keeps its sensitive, source codes in the public repository. Error. So now we have our source code here. So once we commit a code, what happens? Then what? We need a build server. It's called what? This is called a CI server. This CI server is called Jenkins. So what? Jenkins is the technology that is responsible for what? For monitoring and pulling all the changes that comes into this source code environment. So for every commit, okay, it's going to pull it. But now, like, it means that there need to be a trigger, right? So I don't know how many of you own a Tesla car, say, or a Tesla car, right? So a friend of mine brought his Tesla car to my home. He drove from the US, and he told me one thing. He said, "You see this car?" I said, "Yes." He said, "If somebody gets 5 meters close to the car, the car has a system that triggers the camera on his phone. Okay, so wherever he is in the world, as long as he's on the internet, right, he can see somebody, okay, closer to his car. So that is a trigger. So what is triggering his camera to come on and to see his car is those footsteps. Is somebody leaning on his car. By the way, I don't know how many of you have done this or have experienced this. How many of you have leaned on a car of late and the car starts alarming? Bam, 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 bam. You know what I'm saying? That's what, these things are evolving. Like the technology with vehicles today, right, is something else. Like seriously, but at the end of it, some of us don't get. No, I don't get moved with those things, though. But it's something. So people love it, right? Customers love those features. Like somebody bam, 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 bam. You just shift. You are leading on the wrong car. That's what I'm saying. Don't even think of maybe going live. Hey guys, I just bought my my recent Lexus 2024. Hey, I know what the year. Bam, 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 bam in the background. You will not do that video, right? So when the source code is pushed, when a commit or a change is pushed, what happens? We have to configure what is called, okay, a build trigger. So what is going to trigger Jenkins to know, hey, you know what, there is something new in this source code on that repository. So what Jenkins is going to put the code from there, and then what it's going to integrate with, okay, with a technology, with a build tool. After this concept, I think from next week we should be done with Git completely, but what we are going to get into the concept of build technology. How are applications built? That is the question, right? So then what? Of course, so Jenkins is going to integrate with Maven to be able to do a build. So here's what a developer commits a source code. It is raw source code, like we're going to see very soon, right? And then what Jenkins pulls the code and what integrates with Maven to do a build. When this build is done, okay, there is one more important step, and what it has to do with our source, our code quality inspection. Now what we want to be able to inspect this artifact or to inspect the application against 5 parameters. Code duplications. Are there any duplicacy in the code? Are there any security vulnerabilities on the application? Are there any bugs in the code? Are there code smells, right? All of those parameters need to be checked against the quality of the application. Now, someone is going to ask me, like, how do we then know, okay? Like, how do we set those criteria? How do we set those those parameters? Of course, no software just gets it. No company get in the morning and start developing an application. No, there's often planning, right? Between the client and the tech company. They discuss everything they want to see and what they don't want to see. The conclusion of such meetings is what we refer to as project technical documentation. That project, okay, or a high-level documentation, call it whatever you want to call it, but there's a document that documents everything that's supposed to be, developed as part of that particular application. So before developers go to they have a well-cut-out documentation. Now, let me explain to you our role, okay, and our responsibilities as DevOps engineers on this particular, diagram, on this flow. Now, we are solely responsible for for building this entire system, okay, for setting up the automation system. So everything around security on the source code is something that we are responsible for. So therefore, we are responsible for granting access. If a new team member needs access, we can grant the access. If there is need to train someone, I have done that a lot at HP, right? Where you find new DevOps engineers coming, but need to show them around, okay, how to do a pull request, especially. This is the most important aspect when it comes to Git pull requests, because it has the ability to safeguard our original work. So that your branch is what we referred to yesterday as your rough paper, right? I remember in those days when you went in to write an exam, right? Especially maths, right? They will give you your original exam paper, and then you can ask for some rough, okay, so some extra sheet for rough work. Then you only transfer, okay, the confirmed work from the rough sheet to your exam sheet. Otherwise, you're going to be in big problems, right? If you have to solve one way, then you can't say don't consider, then you move to question. Believe me, a root examiner will just just strike over people and move on. Why? Because of course, too many dirty work. You cannot keep stressing the old man. So after we do our code quality analysis with a technology persona cube, what happens? We can then deploy this artifact, and we can upload into a store. This store is called Nexus, right? We can upload the artifact into a store called Nexus. From Next, we can then deploy into a web application manager called Tomcat. It's a deployment server, and we're going to look at those in just a moment. Now, let's do a demo on this application. You see this application here? This is what. So this is one of our. Oops, hold on 1 second. Let's say confidence not too good. Okay, there we go. But why is it not coming on? Anyways, this is Tomcat, right? So this is one of the tools that we are going to study. This is what it's a web application manager. This is just on the low end of it, because as we progress, right, we're going to discover a more advanced interface or environment for managing applications, and that is called Kubernetes. But for now, this is where the class ahead of you is what, and I want to show you how Git relates to all of this. So again, this is our code quality analysis environment. See that? So what you can see today around 3 p.m. there was a deployment, and of course we got a fail on this application. Why? We can inspect it. Of course, you can see the measure. So this is code coverage on new code is 0, so it failed. Duplicate lines of code is 26%. Who wants that in an application? We can now look at the core criteria for this application. It has how reliable is our application in terms of bugs? How secure is the application? What is the maintainability of this application? The coverage and duplication. So SonarQube is going to pick out all of this area. So even if your source code, even if your application is about, let's say is 100,000 lines of code, SonarQube has what it takes to detect if there are any kind of copy and paste in the code. In fact, any kind of security, vulnerabilities. I think by now you should start thinking, oh, now I know why when I go to Play Store to download an application, I see a lot of negative comments as well as good reviews and feedback on that particular app. Okay, so we have so these are the technologies that we are going to use use for this particular application. Of course, we have our server here. That's I think someone get me this one, so I'm not creative, but I think it's admin and then 2023. There we go. Yeah. So you can see this is called Nexus. Okay. So this is like a store that just keeps what is ready to be consumed. So after we have built our application and inspected it, if the QA team or the testers are satisfied with the product, they can approve it to be stored. And from here we can deploy into different environments. So therefore, what are the technologies that we are going to use for this demo? We have our source code. In this case, is Git. We have our Maven. We've already set up that one, And of course, we have our CSR, Jenkins, Nexus, SonarQube and Tomcat. Let's see how to implement the whole thing. First, let's look at our source code. So this is the source code that is responsible for this application. See that? So this is the application, but that is the source code. It says welcome to online, MTN online bookstore. So this is a bookstore. You can log in, you can register, and play around with it. So this is a web application. Let's go ahead and see if we can change a few features of on this application, and then we deploy the whole thing. Then you're going to see how the pipeline is going to be triggered, runs to update this application on the front end. As a matter of fact, we could share this to our users, but we are still very far away from how applications like Amazon.com are built and deployed. Those are applications, not web development. That is very far. What you're doing here is big. Have you ever heard of a web developer who is paid $10,000 a year or even a month? None, right? So our program is not web development. That's why not see us log into any kind of a CRM interface, but we're using advanced technologies to implement DevOps. First, let's try to inspect the source code. So if I go on to my GitHub account, okay, we go back here. Go to this. We have 102 repos here. Then what you can see is 4 hours ago. Let's check it out. Now this repo has it has 4 branches. Now, if you look at the master branch, you're going to notice one thing. That the most recent change on this repo, I couldn't always say was 7 months ago. But if I go to the branch where I'm working, it's November 18. You see that one? Now you see you see that there've been changes on the repository. Okay, you can see what this is. 4 hours ago, there was a change on the web content. Then you can see 4 hours ago, there was a reverted change. Then again you can see that 5 hours ago, you see some files were added and some files also changed. You can see all the files that have changed in this repository over time. So you can now we can it says I even see says this branch is 28 commits ahead of the master. This is exactly what we want to be able to implement even in the working environment. So we never find ourselves doing rough work on the master because it's dangerous in most environments, right? The master branch is is linked up to the production environment. Whatever gets to master is due for production deployment. So we really never want to mess up with our master branch. Is not a good practice. So the best practice is to do everything to the pull request and never really move ahead to merge your own pull request. Pull request must be reviewed by a senior team member in the team and merged if it meets the standards. So now let me explain to you why some pull requests may not be merged and some they will merge, because in most cases, we have set up build automations, okay? For every change is there's a build. So if you perform a change on the report and then we see a fail. So Jenkins give us a failed build like this. Or because of your change, what happens? There's a fail on this project. Why on earth would I move on to merge that particular change into the master branch? Okay, it doesn't make any sense. Okay, why? Because it is failing, right? So we better fix this, okay? Before merging it into the dev branch. Because if it failed on your branch, it simply means that if we merge it into the dev branch, is also going to fail. And again, if we promote from the dev to test, of course, our testers are going to advise us, oh, you know what, we cannot move this to staging. Okay, it's not qualified. It's below the standards. But does that mean that we cannot override them, especially with our African mentality? We can but forget about that. Okay, it's not. That's very far from it. Okay, we can move on. Why? Because we have a sign-on. Okay, the developers, the QA must approve that yes, this application meets standards. But how can we approve this type of an application with bugs in the application? Over 34 vulnerabilities. Okay, 1 on 5 port smells. The coverage is 0%, and we have 10.7% duplicate lines in this particular application. Definitely it's not going to near our production. We can't even save it. Okay, so even if the app is working on your phone or on your computer, it's good, but it can't go to the market. Why? Because we are going to get terrible reviews. It's going to break production at some point. And someone said they used to say that a broken courtship is what is better than what than divorce. So what is what it's preferable to what to keep bugging the developers to fix that issue than to go to production and what then have to divorce with your customers. Why? Because they are not happy with what you are giving them. Okay. So now that's what let's look at this again. So we go back here and what we see is what this is an application. That's what let's look at how Jenkins, okay, comes into the whole picture. Because what this is where things become a little bit more interesting. Let's look at the clone part here and what this is this is the source code for what for this application. This is the library. Okay, this is the source code of our application. This is why source code management is what is crucial in everything we do. Okay, very, very crucial. You can't just do anything on this particular stuff. On the master we have just two commit, but what on other branches? See, look at how many branches we have here. So we have different actors working on this repository. You can see this is Temban, you can see Jack, follow that, call it and all of that. That is what. Let's go and what. Let's say what we want to change. Let's deploy a new version of this application. Now what? That is going to change what? Change welcome to online books and say what? And say class 24 DevOps engineers welcomes you. That's all I'm saying. So if our users were to come back to this app tomorrow, they should see a new message here. Or what? Let's just change what? Let's just change just the happy learning. And then what? We are going to commit the change, and then what? You're going to see the magic. What happens? Let's copy this. Because what? This is part of the coding. That's part of the application. So what? I'm going to go back to my source code. And what now? We have a lot of tools that we are going to study also as part of what? As part of source code management. There is what? There is VS Code. It's a code editor, a very good one. You cannot miss using VS Code at work. Trust me. And there's one other called Sublime Text. All of these we are going to introduce as we progress with the course. So now let's search for this particular word in the entire code base. What? Happy learning. It occurs in one file. So we're just going to just replace it let's do class class 23 DevOps engineers welcomes you welcomes you all. That's a new one. That's what we want to see on the front end. Therefore we have to modify the back end. I want to click here and we are going to implement this change. Something has changed now. Therefore I can run git set to here. See that? Now only one file have changed the web content /index.html file. I'm going to commit this work. Git first of all, git add. So now one of the beautiful things with VS Code, it tells you the branch on which you are working. See that? That's my branch. Therefore, I can run again. Git set to here. As you see, that file was modified. I can run git commit here. -m. And again, let's see changing from end to class 23. DevOps rules. That's it. Then again, that's here. What do we have there now? Let's do a git push. Origin what should I be pushing? I'm going to push to my branch, November 18. There we go. That's on my branch. I don't have to think about anything on GitHub now. Why? So I just move on to my Jenkins and just wait. See that view what view number 8 is now being triggered. Let's see what happens. So what you're going to see you're going to see Jenkins automate what? Automate the entire update process. So what, this is what companies like Netflix, Facebook, Instagram are implementing, because they have tons of features to update. So first, what you're going to see is going to what is going to you can again just look at what the console output if you want to, right? Look at the console output, so you can see what you can see how this application is what is going to be built, right? It's building, it's compiling, it runs it, okay, the code quality inspection, it gives us a result, then what it uploads the application to an Artifactory, and of course what it deploys to the various environments. But look at something here. We have something very cool that we were able to implement. So what? See the application? It deploys to. Then what? It's going to deploy this app to what? To dev. Then what? It has what? It has put to all of these environments. But what? Something else is missing. We are what? We are implementing, okay, a manual approval before what? The deployment to production. So in this case, this is to tell you that what the same way you don't just take your production to the market without kind of getting a feedback on it, right? You must be very careful before taking anything to the market. But that's why you see, if you are into flyer designs, you want to make sure that the flyer is top notch before it goes out, right? No errors, no anything. So we can let's proceed. There we go. See this? It's going to deploy into production at the moment. So it has deployed. Let's refresh the application. Now you see that we still have happy learning. But now, if a customer now comes, they're going to what? See that? So we have what? We have updated, okay, the version of the application. This is why sometimes you log into your WhatsApp and there's already a new feature there. You log on most of the web apps that you like, they are adding new features like every day. How are they doing that? It's through what? DevOps. Okay, so this alone can give you as a build and build and release engineer, Jenkins engineer, okay, QA specialist. I have a student who works for a company that his job is just code quality analysis. This is all he focuses on or at, right? So in this sector there are a lot of responsibilities and there are a lot of opportunities just on this real. So we are responsible for implementing automation. How we get here is what you are going to say when we get to this chapter. Let me show you now. To this. So this is where we are at the moment. We are going to move to. We're just 2 steps away, right? So when we get to, of course, application build, test, all of that, we'll cover all of those, fundamentals. Then move on to chapter 4. Okay, Jenkins handles automation. So when you get you are going to be equipped enough to be able to implement, okay, this entire process. So now if we go on to our this all of this application has been updated. So if I go to test, I'll see that version says class 23 DevOps. Welcome to our M10 online bookstore. If we again, let's go back. If you go to staging, right? This is staging here. You can see again the same thing. Welcome to. All right. And again, if you go back to the other environment, this is prod. Okay. You see the same thing. We have updated our online bookstore application, right? And of course, you can register, you can log in, you can do a lot of things. So this is just part of what we are working towards implementing. Jenkins is a platform that you cannot meet on your resume. That's not the fact. Everything you saw in this demo is Super, super, super important. Okay. Let's end here. I don't want to mess up your brain with too many things, but what? This is where you're getting to. So what? Get ready mentally and be excited. That's the point. Okay. Let's stop the recordings here.